Hello, I am Mani Malarvannan. In this video, we will look into how generative AI and zero knowledge proof in cryptography can be combined, and we can create various use cases that's going to benefit both AI technology and also the blockchain technology. As you all know, AI has been forefront in almost all the industries. It's going leaps and bounds day by day, and there are more and more tools and technologies are coming. Similarly, in the cryptography, there are various blockchain technologies, various blockchain initiatives, projects are all coming up. In this presentation, we will see how we can combine the zero knowledge proof within the cryptography with the AI technology so that both can benefit from each other. So, what is generative AI? So, generative AI is basically, I'm sure almost all of you used the ChatGPT. You give a prompt, you ask a question, and then based on the question and the context you provided, the LLM model, the ChatGPT produces an answer. It could be as simple as what is the capital of United States of America, or it could be as complex as chemical equation or a mathematical problem. Whatever you give, the LLM produces response from the knowledge that it gained based on the training it went through. So that's fundamentally the generative AI. It generates responses based on the user input that you provide. And we can use zero knowledge proof so that the AI technology can make it more robust so that it's not going to deliver unintentional internal data that it has been trained so that all the user informations can be protected. We will get into the details. So for now, you can understand that the generative AI generates responses based on user questions. And one of the main concerns of the generative AI is the privacy issues that is being part of the generative AI technology. See how the generative AI technology works. It's whatever data the companies they found on the internet and the books, research papers and everything, it all being trained through that data. Sometimes there might be some private informations that could be trained within the LLM model. And if you are using prompt, you can gain internal knowledge of that private informations that is unintentionally being incorporated into the LLM. So you can, of course, the ChatGPT or any of the popular LLMs like Google, Gemini, or other technologies, Mistral, Anthropic, all those they have protections for the users so that if you ask a questions that is going to reveal the internal private information, it's not going to do that. But sometimes you can have a prompt injection or any other methodologies, and you can able to retrieve the internal informations about the data. So we need to come up with a mechanism so that the generative AIs, the LLM models are not going to reveal the internal information. That is a one aspect of the zero knowledge proofs we can use. Another aspect is bias and fairness. So whatever the question you are asking, the LLM needs to answer based on the general information it gained. It shouldn't be taking care of who you are and what type of belief you have, and it should be able to give the scientifically proven responses for the users without any bias. So it should be fair for the user to respond to the user questions. And another important factor within the privacy is the regulatory complaints. So it needs to make sure that the LLM models are all following the regulatory requirements based on where the user is physically located. If the user is based on Europe region, that it needs to follow the rules and regulations of the Euro region. If the user is based in US, then it needs to follow the rules and regulation, the regulatory requirements of the US government. So all those issues that we discussed in this slide is going to be solved using zero knowledge proofs. We'll get into the zero knowledge proofs next. So what is zero knowledge proof? So it's basically the zero knowledge proof is you want to prove that who you are without providing all the informations. For example, if we are going to a bar, the bar attender will ask, okay, are you legally drink a beer, alcoholic beverages? So how are you going to prove? You will have a state issued license or any other mechanism to show that you are legally more than 21 or whatever may be the age based on where the country is legal age limit to drink alcoholic beverages. So when you show ID, the ID will have your name, your date of birth, and maybe your physical address, your house address. But all those informations, the bar attender, you don't have to reveal those informations. The bar attender needs to know whether are you legally you can able to drink. But right now, if you show the your license, then the person, the bar attender can read all the informations. To avoid that, the zero knowledge proof can be used without showing your real ID, without showing where you are physically located. All you need to do is that use the zero knowledge proof technology to show that you can legally drink alcoholic beverages. That's all the bar attendant needs to know. So the zero knowledge proof using various cryptographic mathematical algorithms, you can able to prove that you are legally who you are or your age, whatever may be the security you need to show for the proof. So that is the whole point of the zero knowledge proof. It is completeness. So whoever is going to validate, then that person can be assured that the zero knowledge proofs can't be tampered because it's mathematically being verified. So that is one thing. And then the soundness, if false, then it will instantly tell that you are not legally, you can able to drink alcoholic beverages. And also another advantage of the zero knowledge proof, as I said earlier, you can reveal the only the informations what you need to reveal. You don't have to reveal your address, you don't have to reveal your date of birth. See, for example, if you go to the bar, if you show your ID and which has the date of birth, you don't have to show your age. All you need to show is that you are legally you can able to drink. So using the zero knowledge proof, it is possible to do that. You can able to show only the informations what is required. So there are two main types of zero knowledge proofs. One is the SNARK, another one is the STARK. So there are pros and cons of using those two technologies. In the first case, the SNARK, it is very small and quick. If you want to verify any small informations, then you can able to use this technology to do that. Typically in the blockchain networks, in the layer 2 technologies, if you want to have a proof, then there are many layer 2 technologies are using the SNARK approach. In the Stark approach, it is a large but scalable computation. If you want to validate, you can able to use the Stark. Generally, the LLM models will end up using the ZK Stark mechanism to validate the data that is being generated, validate that the data being input to the LLM models. And another point is the trusted setup. The ZK snarks are pretty easy to set up because it takes less resources to to set up, and also you need to have a mechanism to initiate a temporary trust, and then you can initiate the transaction between two parties. But in the ZK Stark, there is no need to create a trust mechanism, but it takes time to set up the technologies and everything involved to create the ZK Stark. And then the quantum resistance. As you all know, the quantum computing is getting popular, and there are various companies are looking into the quantum computing. And the ZK Snark, you can able to track and you can able to break the technology, but with the ZK Stark, it is a quantum secure. For example, what that means is that using the quantum computer, you cannot able to break it. And the applications for ZK Snarks is the layer 2, various blockchain applications are there. And then for ZK STARK, it is you basically used for LLM models, as I said earlier. So how ZKP zero knowledge proofs can be used in the generative AI? Private data training. See, whenever you are creating the LLM model, you need to get the data to train it. So there are many situations where you want to use the data, but without getting any private informations about the data that is being trained. For example, if we are developing a LLM model for a medical company, there are a lot of medical images exist in a medical company with the user information, a lot of private informations and everything is there within the medical image. But you want to feed the informations to the LLM without providing the private informations of the patients, those image that belongs to, because you have to follow the HIPAA compliance, Privacy Act. There are various regulatory requirements you need to follow. For that, the zero knowledge proof can be used before you sending the data to LLM. You can use the zero knowledge proof technology to make sure that the data you are getting it from the medical images are all secure and there is no information is being leaked, and you can use that data to train the LLM model, and that could be used. And then the same way, when the LLM generates the response, it needs to make sure that it is not revealing any of the private informations that's being trained. So for that, the zero knowledge proofs technology can be used to get the output, send it to the zero knowledge proof to validate that the output is valid, that's coming from the LLM, what it's supposed to come, and then the users can able to read the output for the questions they asked. And another important technology is the secure federated learning. The federated learning in the AI technologies, for example, the Google, Apple, they are all working on training a model within each mobile cell phone that the individual user has. So it's the model is going to run within your mobile application, and it's going to use the data that you are being used. For example, if you are traveling or if you are speaking, all those data is getting stored within that your mobile phone, and then they will be running the model to train, and then they will be sending the data to a cloud server where they will collect from all the users, and they are going to train the large language model within their cloud environment so that they can able to come up with a federated learning from individual users. So when they are planning to do that, they need to make sure that none of the private informations from the individual cell phone is being transferred to cloud networks. So for that, the zero knowledge proof can be used to avoid any of the private information that is being sent, and also whatever the data that is being sent, they can be make sure that in the cloud they can able to use the zero knowledge proof to confirm it is coming from the particular cell phone from a particular user. Otherwise, there will be hackers sending bad or wrong data to the federated centralized cloud network. They can able to send the data and hack the LLM model that's being generated uh, in the cloud. And also the inference, we already talked about the output from the LLM model. In the same way, when a user is asking a question, the LLM model is going to respond to the question. During that time, the LLM models needs to make sure it is giving the correct response for the user's question, and it is coming from the right LLM model. For that, zero knowledge proof can be used. These are all the some of the real world applications we already discussed. The healthcare, private medical diagnostics and drug discovery can applications have a lot of data, which are patients' data that the companies needs to follow the regulatory requirements of HIPAA, other private privacy acts based on wherever the country the model is being trained. wherever the country the data is being used to train the model. For that, zero knowledge proofs can be used. And then in finance, the fraud detection, credit scoring, for all those applications, the lot of regulations are required. For these type of applications, the zero knowledge proofs can be used. And then the other application we already discussed is the identity verification. So you can use your digital wallet to show who you are without revealing any of other informations. For that, zero knowledge proofs can be used. And then in the supply chain, you can use the zero knowledge proof within the entire LLM models. The various AI applications can be used for the zero knowledge proof. And then the road ahead and the challenges. See, the main challenge integrating the zero knowledge proof with the AI technologies, both are it's very in the initial stage. The Even though AI has been around for a long time, the generative AI has been around only for 3 years when ChatGPT use the LLM model to generate the responses. So it's been 3 years, so it is in the initial stage. Similarly, the zero knowledge proof has been around within the blockchain. There are projects are coming up integrating those two technologies so that both can benefit from each other. And there are other important aspect is it takes a lot of computational resources to create the zero knowledge proof and integrate with the AI model. The main thing is the computational time and also the skilled resources who can understand both the AI technologies and the zero knowledge proof so that they can able to combine those and create useful applications for the users. And there are other integration complexities are there, how you are going to integrate so that the users can get the response as soon as possible without delays. So all those issues are there, and there are companies working on in various projects to solve these issues. The one thing is to for the speed up, there are hardware accelerators are being created so that the zero knowledge proof is being embedded within the hardware chip level. So when the request comes in, the zero knowledge proofs can be used to get the answers from the LLM and send it to the users without any delays. And also there are standardization and toolings are all coming up. There are multiple companies are working on to come up with the protocol standards so that both the zero knowledge proofs and the generative AI can be combined for the user's benefit. And another important aspect of LLM is right now any LLM you use, either ChatGPT, Android, or Google, there is no auditable LLMs are available. Auditable LLMs meaning that you should be able to audit whatever the request you sent, the response it generates. You should be able to audit how well the LLMs are doing. But right now, we do not have a mechanism to do that. And once the zero knowledge proofs are integrated with the LLM, for specific applications, then it's possible to audit and any type of regulatory requirements, the LLMs can be able to answer those questions from the regulatory departments that are coming. Uh, Again, this type of use cases, what I'm talking about is not for general LLM models, and more specialized LLMs are going to be created. There might be a LLM will be created for medical imaging or for financial markets. For those type of applications, there is a strong requirement from the regulatory that LLM needs to be auditable so that in case of a lawsuit, then we can go back in the history and understand what exactly the user request or what exactly the user respond happened in a auditable way using the zero knowledge proof so that there won't be any tampering happens in between the request and response. And also another, the ZKML as a service mechanism is coming. There are cloud companies are working on to come up with the service. So anybody who wants to have a zero knowledge proof, they can use software as a service mechanism like that. As ZKML as a service type mechanisms are coming up. So that's all I want to discuss in this video. So the zero knowledge proof is a very common technology within the blockchain, and now companies are working on how they can able to integrate with the LLM. And I have blogs written in the AnalyticKit. If you need to learn more about it, visit analytickit.com and you can learn more about it. And if you like this video, please subscribe to this YouTube channel and also like this YouTube video, and please forward this YouTube video to your friends and family so that we can grow this channel. Thank you. Appreciate your time. Bye.